Hello there. In the last few videos, I've gone over a lot of the addition and subtraction identities that exist with sine, cosine, tangent, and then I even went a little bit further and derived some for secant, cosecant, cotangent. So I wanted to show you what those could be used for from a calculation standpoint in terms of calculating exact values that do not exist on our unit circle. So the two problems I have for you are sine pi over 12 and cosine 5 pi over 12. Now, pi over 12s and units of twelfths do not exist in our unit circle. So how can we use the tools that we have? Well, a little bit of intuition tells me that pi over 12 is equal to pi over 4 minus pi over 6. This is because pi over 4 can be simplified from 3 pi over 12, and pi over 6 can be simplified, can be simplified from 2 pi over 12, and we can see 3 minus 2 would give us the 1 pi. Okay, so that means I can rewrite this as sine pi over 4 minus pi over 6. And once we have it in this form, let's go ahead and use our difference identity. So sine pi over 4, that'd be a times cosine pi over 6 minus cosine pi over 4 times sine pi over 6. Okay, great. Let's go ahead and look at this from the perspective of the unit circle. Sine pi over 4 would be root 2 over 2. Cosine pi over 6, that'd be root 3 over 2. Going a bit further, we have cosine pi over 4. That would be another root 2 over 2. And then sine pi over 6 would be 1/2. And now we can combine these. We get root 6 over 4 minus root 2 over 4. And notice we get a common denominator, so we can write it as root 6. Oop, that was too long. I apologize. Minus root 2 over 4. So we have an exact value for sine pi over 12, okay? Let's try one with cosine. Let's go cosine. I'll divide this screen up a little bit. Cosine 5 pi over 12. Well, I know that 5 pi over 12, we just referenced that pi over 12 would be 3 pi minus 2 pi. So 5 pi over 12 should be pi over 4 plus pi over 6 for the same reason. Now, I should say that these are angles I'm pulling out that I happen to know equal this. You could use others. For example, if you wanted to get pi over 12, you could use 5 pi over 4 minus 7 pi over 6. And that would be, as long as you're using two consecutive values that differ by a pi over 12 on the unit circle, you could use whatever you want. But it's also always nice, in my opinion, to go with the first quadrant. Okay, so let's rewrite this as cosine pi over 4 plus pi over 6. And now we'll use the addition cosine identity, which is cosine pi over 4 times cosine pi over 6 minus, remember addition here means subtraction here when it's cosine, sine pi over 4 times sine pi over 6. So we get root 2 over 2 times pi over 6 would be root 3 over 2, okay, minus another root 2 over 2 times 1/2. And look at what we get before. We get the exact same answer. We get root 6 minus root 2 all over 4. Interesting. Now, it's not too much of a stretch to imagine how we could extend this into tangents, cotangents, secants, cosecants to create additional solutions. If you'd like to see more videos like that, let me know. Have a good day.